Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me RouterBob. I have a great video for you. We're going to make an electric solid body mandolin. Now, a mandolin basically has two components. You have the body itself and you have the neck. Each one of those has machining from both sides. So if you think about it, there's actually 4 setups. Well, what I wanted to do was to take one of our Pro Series router that had a tool changer and a vacuum system on it and do a setup that included all 4 of those. So theoretically, when you run the program, you get a mandolin. And I call that setup the Mandolin Factory. So that's what we're going to do. Now, let's take a look at the machine before we get started. You know, people ask me all the time, why do the ShopSabre CNCs cut so well and why are they so accurate? And I said, well, there's an easy answer to that. It's the frames. All of our frames are structural steel, all welded, so the base frame is one piece, so there's no room for vibration. All right, we combine that also with a structural steel gantry and structural steel gantry support. So that's what you start with. Now, as you build on that, then things start moving, and the way motion is controlled on here, we start with precision contour guide rails. So all the movement of the machine is along those. What actually makes the machine move are ball screws. So we use a precision ball screw in all 3 axes. Now, you know what's funny? People ask me, well, is a ball screw better than a rack and pinion? Well, yeah, it is. And it actually is. It's more accurate. They don't have as much play. They don't use rack and pinions on metalworking machines. On this particular machine, this is what we call a machine tool grade CNC router, so by definition it has to have ball screws. All right, and then what makes that motion is actually the drive motors, and we use a Mitsubishi drive platform for that. Now there's one final component in motion control, and that's the machine control itself. Let's go take a look at that. This machine features our ShopSabre MMP machine controller. MMP stands for Mitsubishi Motion Platform. So we built the whole control structure on a really rock solid technology. But you know, there's another part of the machine control that relates to the operator, and that is how easy is it to use, how easy to learn to use. And we were really worried about creating something that was too technical, that you had to hire an engineering type person. And so one of our goals was to create something we could run with a really simple interface. Well, we started out and we said, well, let's put that interface on a Windows screen, and here's why. There's 2 really features that help us. One is that lets me, because it's a Windows system, I can tie it to our network, so I can send the files directly to the machine control on the network. The other thing is I can actually run software on the machine control. So nowadays there's things we do at the machine with software on the control. So Windows gave us the ability to do that. Now, here's what I really like about this controller. There's one screen. You don't have to fumble through. Let me show you how easy it is to run a program. All I do first is I go to File, I load the program, it's loaded, I hit a button and it shows what it's going to look like, and I can tell immediately if that's the correct program, and I hit the green button and the machine starts. It's that simple. Now we've talked about motion control. Now let's talk about cutting. So let's go over and take a look at the spindle system. This machine has an HSD ATC spindle. We offer those in a couple of different sizes. ATC stands for automatic tool change, and this machine actually has a 5-position tool changer. You know, while we're talking about the spindle, I want to talk to you a little bit about engineering, because we use some really sophisticated engineering software here. We basically wanted to do some research to determine, is there a way to increase the rigidity of the tool in the material without lowering the gantry? So is it possible to do that? And so here's what engineering came back with. They came back with this stiffener system. And let me tell you the story on that. So they put all this stuff into the engineering software, and they did all this testing, and that solution came back pretty good. So we ran it on a machine and we found it really worked. So then we refined it a little bit by doing some of these cutouts to reduce the mass. Now, why is mass important? Well, it's real important. Here's why. If you think about the mass that's here, mass is weight with gravity. All right, so what has to happen for this to move up and down? Well, first off, we have a precision ball screw that raises it. But you know, because of gravity, it's a lot easier to lower it than it is to raise it. Well, so how do we overcome that? And we did that with a balancing cylinder. So here's what happens. We use compressed air basically to take that mass or weight off, and it's just as easy for the ball screw to raise the spindle as to lower it. All right, so now what's the actual impact of that? Well, there's something a lot of people don't understand, and when you do 3D machining, the actual speed is determined by your slowest axis. And almost on all these machines, it's going to be Z. So if you can improve that, you can make 3D machining a lot faster. So that's basically why we did that. And so you'll find that these machines are really fast when you're doing 3D surfacing. Now, let's go over and look at the table on this machine. This machine actually has a vacuum table. This one happens to be out of a specially treated MDF that we developed. We also do the same table in phenolic and in aluminum if you prefer that. Now, this machine says 408, but it's actually wider than that. If I take a tape measure out here, I quickly find out that the machine table is 5 feet wide, and the machine has full coverage at those sizes. Now, what that means for you is if you need to cut 5 foot wide material like Baltic birch, the machine will do it. So that's a really nice benefit of having this set up like that. Now, something else I really like is how we handle vacuum. Now, first off, on the table surface, you see these large ports. And so we basically use real large ports to bring the vacuum in. Those actually tie into a vacuum plenum, and then it ties in with a real big tube that goes back to the vacuum pump. But if you notice, we also have valves to control those. Now, our particular setup here, we're basically going to be working on this part of the vacuum table, so we'll just shut the rest of that off. So it's going to be really nice. Our setup is going to be really good right here. All right, now, let's go up to the front office and let's talk about how we actually set up this Mandolin factory. You know, there are a couple of product categories in woodworking that are really, really popular. One that comes to mind are clocks. People really, really like to make clocks. Another one is musical instruments, and specifically guitars. There are lots and lots of companies that are custom guitar builders. So I really wanted to look at that a little bit, and I decided I wanted to build a solid body electric mandolin. And I wanted to do the body, and I also wanted to do the neck. Well, I couldn't find a solid model to buy or download anywhere, so what I ended up doing was ordering a set of plans from England. And hoping they were CAD plans, they were actually paper drawings of full size. So the first step was to go from that into a solid model. And so that's basically where I started this. But I really wanted this demo to be a whole lot more. I really wanted it to be about much more sophisticated vacuum fixturing, because that's almost become a lost art. And I decided, well, if I were really going to make mandolins to sell, I need a pretty quick, easy system, and so that's how I focus this setup, and I think you're really going to like it. All right, before we get into the setup, let's take a look at how the solid model actually came out. All right, this is the actual solid model that was developed from that set of plans. Let's take a look at it. Basically, there are two parts to a mandolin. There's the actual body, and this happens to be a solid body one, and you see there's machining on both sides. That's what makes this tricky, because if you notice, we've got some 3D surfacing here, we've got some boring on the back side, and then of course we have the pockets that get cut out for the pickups and those kinds of things. So that's the first part, all right? And then there's, of course, there's a neck. Well, the neck's got machining on both sides also. All right? Now, this is called a Mando caster. And because the neck is basically modeled after a Stratocaster, that's why they call that. But it's a really nice. It's really hard to draw, but it's a really nice little product here. So I thought this is a great way to do a demo. Now let's talk about what has to be done to make this. Well, both of these have machining on both sides, so that means you're going to have a setup for each side. So that's 2 for the body and 2 for the neck. So we're basically going to have 4 setups. So we machine one side, then we flip it and machine the other, the same on the other part. So let me show you how I kind of planned on doing this with a fixture drawing. All right, let's talk about what's really involved on the machine to make all this happen. We know we have to machine both sides of each part, but how do we accomplish that? Well, remember our machine is a 408 Pro Series, and it has a vacuum table and it has part locator pins. So one of the things I want to do is create a fixture board that I can take on and off the machine, and I'm going to integrate that with a part locator pin so the position's always accurate when I use that. Now you can see on the screen here, you see the parts for the mandolin, and you also see this board, and actually there's 1, 2, 3, 4 holes. Those happen to correspond to the part locator pins. So that way, that gives me a consistent way to take this on and take it off. Now, the next issue is, how do I hold the parts? Well, you know, double stick tape's fine if you're prototyping. But if I'm doing production, I'm probably going to try to use vacuum. And so what I did was I created a vacuum fixture that's based on our vacuum table. So the parts are actually held in place with vacuum. So that makes it really, really easy. Now, eventually, once I test everything, it's possible to have run one program, and every time you run it, you get a mandolin. You get a body and a neck. That's why I call this setup the Mandolin Factory. Now, let's look at this in a little bit more detail. All right, let's open up the Toolpath panel for RhinoCam, and I'll kind of walk you through how we actually attack this. Well, first off, I've taken the body and I've positioned it where the back side's up, and I normally do the side that has the least machining on it first, and so that's what we did. Now, okay, the blank is held to the table with vacuum, and that works out really well. But you know, one of the things when you get into this two-side machining, thickness is real critical. And so the first thing I do is I face it. So I take a cutter and actually it just runs back and forth the blank, and it cuts that perfectly flat. So I start with a really nice smooth plane. Then the next thing I wanted to do is I wanted to basically cut part of the way through. Now, here's what I do with that. I basically cut part of the way through. I actually leave about 30 thousandths of material, because as thick as that is, I'm going to do multiple passes. But when I get finished with it, I don't want to have to sand very much. So basically, I'm going to cut part of the way through from the back, part of the way through from the front. When it's done, the last step I'm going to do is take a 3-flute finisher tool from Vortex and do a climb cut and take that 30 thousandths off, and hopefully I won't have to sand very much if everything works out right. So that's kind of the thinking with that. Okay, then we basically attack the surfaces. There's surfaces on the edge here, and I basically attacked it from 2 different directions, so I make sure it's smooth all the way around. We've got some holes on here, so I pocketed those. And now there's some other holes, and let me see if I can show you something. Actually, I might be able to do it this way. Now the blank doesn't show that well. Let's see. Let's ghost that. Okay, now think about this. This is the blank. So that's what I started with. Now, what I'm doing right here is I'm actually drilling 2 holes. All right, well, you say, why are you doing that? Well, I have to be able to flip this, and the front has to line up with the back. So the way I do that is I basically drill 2 holes here. In the next setup, I've got 2 steel pins that stick up there. So that sets down on top of those pins. That aligns it and vacuum holds it down. So that's basically what's required on that first setup for the body. Now let's look at the other side of it. Okay, so the second process then is to turn the body over and machine the back side. Now there's a lot more machining on that, of course. Once again, we're still going to we're going to face it just like we did before. So that basically gives us a flat surface and controls the thickness. And then once again, we're going to do our 3D surfacing on the corners. Yeah, you actually could buy a router bit, order a router bit that's a rounder if you wanted to, but you're still going to have to deal with some of this other stuff. Okay, then something else we have in here is pocketing. Now, see, what we basically have done here is just cut that out deep. And so you look at each feature, and you basically toolpath it. So now, actually, here's something interesting. There's actually some holes that are machined deeper in here for clearance for some kind of nuts that mount on there. So I made a provision for that. Then here's this area. Now this is the pocket that the neck fits in, all right? And then this is actually something about the string fits back here. There's a little mechanical thing. And then this is a slot, and then what happens is on one of these instruments you have a cover plate on here that covers a lot of that up, and so that passageway for wires actually disappears. And then once again, there's a profiling cut. Now remember, this is the final pass, so there's the profiling cut, and then this is the finish pass. And you know, the finish pass is a single pass. This cut, once again, we step down, and the outside perimeter is still 30 thousandths large, so we basically clean that up, and hopefully with the 3-flute finisher and climb cutting, we should get a really, really nice surface. I said before, because I don't like to sand. All right, now let's take the same approach and look at the necks. Okay, let's take a look at the neck and let's see how we approach that. Now, once again, we started with a rectangular blank or block of wood, so let's see what that looks like. That's what they look like. So that's what I started with. In fact, you know, it's funny, we can ghost that. You can see the part hiding in there. If we look at the front, whoops, you can kind of see how that's positioned. So basically what I did was I took that model, I took the blank, and if that model is in the middle of the blank. So what's going to happen first is I'm actually going to machine this off. I'm going to face it like we did earlier. When I turn that over, then this amount of material will be left. It'll be taken off at the next operation. But let's look at this. All right, let's get our blanks back off. Get our rendering on. Now, the first thing I'm going to do, as I said earlier, is I'm actually going to face it for the same reason I did the other one. You know, once again, these parts are oversized and sometimes they're not smooth, sometimes they're hard to hold down. Right, so that faces it. And then once again, now in this area, there's not a lot of machining on here, but this area up here is actually machined down. So I basically did a rough pass. Now there's something here I didn't show you, and that's these plugs. Now what these plugs are used for is they're actually attached to the model, and they help hold the part down, and they also have the locations for the pins. All right, so we'll turn those back off. All right, so there's our rough tool pass, and then we come back in and we do a finish pass. So that machines that. Now remember, this is still connected, even though we've machined that down, this is still connected rigidly through here, so it's a very solid connection. All right, the next thing we do is the holes, and so there's the holes for the keys. I believe they call those pegs. Okay, and then here's some more holes. Now these are the holes for the rotation. So those are the actual holes that fit over the pins. And then we have a slot down the center. And that's optional. Not all of them have that. It's some type of stiffer for the neck. All right, so that's how we do the first side. Now let's take a look at the other side. Here's the other side of the neck itself. You know, there's something that the first time I started making guitar necks, something occurred to me. You know, basically when you create this, you have a contour here, a cross section here, and the software basically fills that in. Well, so that shape determines how the neck feels. And it occurred to me that you could actually vary that shape and make custom fits. So you theoretically could make a guitar that fits a person's hand very well. So that's kind of what leads you into the custom instrument business. Okay, let's look at once again how we approach that. And of course, we've still got our plugs attached. All right. So the first thing I'm going to do on that one is horizontal roughing. We'll turn that on. That came out pretty good. And then we're going to do our finishing. And then we'll do our, now when I get ready to cut this out, I basically come around here and just do multiple passes. And then we do finish cuts here in the ends, and that's so that it basically cuts it away from those plugs. Once you do that, the basic, both sides have been done. Well, I wanted to show you a little bit about how we approach this. You know, sometimes one issue is how do you draw the thing, and next is, okay, now I want to make it, and I want to make a bunch of them. How do I set my machine up to do this efficiently? So that's really what I wanted to do with this video. So what we'll do now is we'll basically go out to the shop, we'll look at that fixture setup, and we'll start running some toolpaths, and hopefully we'll get a complete mandolin during this video. Let's go out to the machine. Let's take a look at the actual setup for this. Okay, this is a fixture board. Now, when we have the machine operational, we'll actually have the 4 pins up, and that's what gives us a repeatability. That's how we locate this. Okay, now if you look a little closer here, you'll notice that around each of these 4 areas, I've got a shallow cut there. That's so I know where to put the blank. I just make sure the blank lines up with that. Inside of that, you'll see some black gasket material. We get that from All Star CNC products, and basically the cross section's about 1/4 by 1/4. The groove is about 3/16 deep, so that sticks slightly above the surface. That works really well if wood's a little warped. Then inside of that, we have a vacuum channel and then 2 holes drilled down to access vacuum from underneath. Now the way we've got the table set up, this is over the first zone and the other 3 zones are turned off. So all our vacuum is fed to this setup, and we're tied in with our F4 vacuum system. Okay, now there's another type of gasket here. The reason on this initial one I use this type of gasket is because sometimes the boards that you get are not really flat. All right, now we know over here they are going to be flat because they've been fly cut. This is another type gasket material that has adhesive on it. You basically glue it down and then you cut your channels in there. So it works really, really well, especially if you've got some real small parts that you have to make. Okay, now let's load the blanks onto this fixture. Okay, we're almost ready to cut. Now you've noticed I've got all 4 blanks on here. We're actually going to cut 2 first. We're going to cut the back side of the body and the back side of the neck. The reason I put the other 2 on there is to just seal when we turn the vacuum on. So what we're going to do now is we're going to cut this piece on the back and this one, then they'll flip over and we'll load 2 more over here. And once we have everything set, we can actually create an entire electric mandolin. Let's get started. Well, our mandolin came out really, really good. Here's the body. Boy, the edge finishes are good and the accuracies, which you would expect on this machine. It's got all the little machine cutouts and stuff, and the neck is really nice too. All the little transitions are smooth, and of course it fits in that body, so there's your 2 parts for electric mandolin. You know, one of the reasons we did this was to also show you a different way to fixture things. You know, I've been in this so long, this is how we fixtured things a long time ago. We didn't make kitchen cabinets and there wasn't flow through. Now, the next step for this process would be now to actually create what I call the Mandolin Factory, and here's what we would do. We've tested all the toolpaths so we know they're right. Now what I want to do is I want to create one program that does all 4 of those, all right? And then once I get that in place, then we'll do what we call amortizing tool changes. What that means is you start with 1 bit and you do all the operations on all 4 parts with that bit before you put it away, so it saves you time. Now, there's another time part of this, and think about the role of the machine operator. Okay, if we combine operations and make the program longer, the machine operator sets it up, and they're free to actually go close by here and do other operations. Well, think of it as free labor. You've already paid the operator to run the machine. The labor he's putting in over here or she is free. All right, so our next step would be to do that. Well, I hope you enjoyed this. There's something therapeutic about woodworking, and it's really, really fun to do this. If you have any questions, you can contact us at ShopSabre.com. Thank you for watching.